This is the Plate Boundaries video with Mrs. Leonard. For this video, you are going to need your science notebook because there is no input page. So you're taking notes right in your science notebook and a pen or a pencil. Go ahead and set up your notes. The title is Plate Boundaries. That should go at the top of page 29. Don't forget to put the date. You can put today's date there. And make sure you set up your table of contents as well by putting plate boundaries in your table of contents and page 29. Our learning objective for this video is that you will be able to describe the movement at 3 different plate boundary types and identify them on a map. Be sure to write this underneath your title on page 29 in your notebook. So we've been talking a lot about continental drift, about earthquakes. This is a picture of all of those different earthquakes that we saw last week, or this week if you're listening to this early. And you can see all of those different earthquakes are taking place at the plate boundaries. So plate boundaries are the edges of tectonic plates where 2 different plates come together. So you should be recording that definition underneath your learning objective in your notes on page 29. So we've got a couple of different plates here. So while you are recording that, I'm just going to kind of point out these different plates. So this right here is the boundary between the Pacific plate and the North American plate. And right here we have a bunch of earthquakes that take place. And so we're going to talk about what happens when these 2 plates come together. And this boundary can be either where 2 plates are colliding, where 2 plates are sliding past one another, or where they are diverging, where they're moving away from one another. And just like you saw in the lab, we have different geologic events that can occur here. So anytime you have earthquakes, they're usually occurring along these plate boundaries. Anytime you have volcanoes, they're usually occurring along plate boundaries. And anytime you have mountains being built, just like we saw in our lab, usually this is the place where 2 tectonic plates are coming together. Okay. Make sure again that you're capturing this, what is written on the slide in your notes. So the first boundary that we're going to talk about today is transform plate boundaries. And this is where 2 plates are moving past each other in opposite directions. So we might have one plate moving in one direction and another plate moving in the opposite direction. So they're not colliding, they're not moving away from one another, they're just kind of sliding past one another. And the result with that is that we can get a lot of earthquakes. And you saw in the lab where rivers or maybe some other landmarks can become offset from one another. So if I'm going too fast for you, remember you can pause and go back so that you can see what you need to write in your notes, okay? We do want to create a picture of this in our notes. So off to the side, maybe off to the right or in the left margin next to what you just wrote, you want to draw a picture of this. This is an actual, like a block diagram. I'm not all that great at drawing things. So instead, what I would just do in my notes, I would just draw this so I can see that there are 2 plates next to one another. And I would just draw one of them going this way and one of them going that way. And that gives you enough of an idea about what is happening with your plate boundaries. Now, if you want to get really fancy and you want to make it a 3D diagram, you can do this and just turn it into like a little block. And then that kind of gives you that idea of a 3-dimension. Okay. The best example of this is the San Andreas Fault, which is out in California. This is what causes most of the earthquakes out in California. And the reason for this is we have the Pacific Plate out here on the left-hand side, and it's moving kind of northwest. And then we have the North American Plate here, and this is on the right-hand side, and it's moving southeast. And so these plates are sliding past one another. And the problem is when they slide past one another, they usually get kind of stuck right where the two plates meet. And if that happens, then the rest of the plate is moving, and eventually stress builds up, strain builds up, and eventually those two plates will become unstuck. And when they become unstuck, that is when we get the earthquake. The second one is a divergent plate boundary, and this is where two plates move apart. I like to think of that word diverge. So if things diverge, they are moving apart. And you saw this in the lab as well. This was when you had our two plates moving apart, and that's because the mantle, remember, is coming up and the magma comes up and then spreads those two plates apart. And this is the very first thing that we talked about, where this is how continents started to first move apart, how they started to drift apart. And the result of this is that we end up with mid-ocean ridges, and you can see on our picture here that we have the mid-ocean ridge forming, and we can even see some of those little volcanoes popping up on the surface of the ocean. We have seafloor spreading, so the ocean is actually spreading, that seafloor is spreading apart. And we end up with new ocean crust being created. So where we once just had land, now we have some ocean crust being created. And of course, all along that boundary, just with any plate boundary at all, you're always going to get those earthquakes and maybe some volcanoes as well. Now, some people might not realize this, but there are some continents that are breaking apart today. Yes, today, even as we speak, there are continents over in the Mid-East. This is called the Africa Rift. And right along here in the Africa, near Africa, Saudi Arabia, and the Middle East, that area, this is splitting apart. We call this continental rifting, where we have two plates that are separating. And when they are separating like this, we end up having the plates moving apart, and we end up with these new oceans that are being formed. And so you can see here, if I erase this, you can see that we've got some ocean forming right in this area, which is really amazing. So we can start to see where these two continents are going to separate and drift apart. I mean, obviously this has taken millions of years, and it's probably going to take millions of years longer for us to actually see this, but it's happening right now. So just like we did before with our transform plate boundary, let's draw a picture of what's actually happening so that we have that in the margins next to what you wrote about divergent plate boundaries. Again, this is a fairly complicated picture of it. If I were to draw this in my notes, I might draw my two plates again, and I would just draw two arrows showing these two plates moving apart. And again, if you want to make it 3D, you can do this to kind of show that these are blocks that are moving apart. And I really like this series of pictures because it kind of shows you how when these two plates are separating, are diverging from one another, before you get that ocean, we actually start to get this rift valley. So this is just a valley where the continental plates are separating apart. And so you end up with this valley of land, essentially. And eventually, if those two plates continue to separate, water ends up filling in that valley, whether it is from rainfall that washes down a mountain and from a river, or it might actually be a nearby ocean that eventually finds its way and flows into this lower valley left by the rifting. And then eventually over time, as the continents separate even farther, then you start to see this oceanic ridge, this mid-ocean ridge forming in the middle of your ocean. And in this map view, you can actually see this is an actual map that some scientists made of the oceans. And you can see here is the mid-Atlantic ridge, right, all the way along the Atlantic Ocean. And there's also Pacific. You can see here's the Pacific Ocean ridge, the mid-Pacific ridge. But the Mid-Atlantic Ridge is a pretty common example of a mid-ocean ridge where the plates are diverging. All right, time for your first question. Which kind of plate boundary is this? Make your choice when the question pops up. All right, hopefully you figured out that that was a transform plate boundary. And we know that that's a transform plate boundary because these plates are moving side by side past one another and they are not diverging. If this was a divergent plate boundary, then we would see those two plates moving away from one another like that. All right, so the last plate boundary we're going to talk about today is convergent plate boundary. Converge, when you converge, you are making two things go together. And that's exactly what happens in a convergent plate boundary. The two plates are colliding, they make a collision. Now, collide is kind of a bad term because it's not like when we think of a collision, we think of two things colliding together very quickly, right? Like cars, making a collision. And as we know, these plates are not moving very quickly. So how can we really say they're colliding together when they're moving so slowly? But nevertheless, they are two plates that are coming together. And we saw in our lab that when you have two plates coming together, you can get earthquakes, and you can also get these volcanoes that we can see right here. And in this case, you can get an ocean trench, island arcs. An island arc is just exactly what we see here. It's a whole arc or a whole line. Usually the line is curved like an arc, and so that's why we call it an island arc. But we can also get these large mountain ranges when two plates are colliding or coming together, like we saw in this picture here. So we kind of need to talk about the different types of convergent plate boundaries, and you might be running out of room at this point. So if you are running out of room, this is going to feel kind of weird. Don't go on to page 30. I know that right now you're on page 29. Instead, I want you to continue these notes on to page 28. So you're actually going to go backwards in your notes to page 28. So if you're running out of room, go ahead and go over there. You're probably going to need at least maybe 10 more lines for the information that we are going to do for the rest of this video. So we're going to talk about the three different types of convergent plate boundaries. So we're still talking about plates that are coming together, right? But in this case, we're going to talk about if one of those plates is an ocean plate and the other one is a continent plate. So oceanic crust and continental crust. And what usually happens is that the denser oceanic plate is subducted under the continental plate. So what do I mean by that? Well, if it's subducted, that means when one plate goes underneath another one, and we call that subduction. So if we were to look at a side view of this, we have maybe your ocean plate here, and it's colliding with your continental plate here. Because the oceanic crust is actually more dense, it's heavier. It's made of usually rock that is called basalt, if you remember that basalt rock from our igneous rocks, and it's denser, it's more mafic, and it tends to go underneath the continental plate. And so we call that subduction. This is a great picture of what is happening. We've got our oceanic crust right here, and when the two of them collide, it collides with the continental crust. This oceanic crust goes underneath the continental crust. And a couple of really cool things happen when this occurs. First of all, right where those two are meeting and where you have the oceanic crust subducting under the continents, you end up with this low area, like a valley, and it runs all the way along the ocean floor where that plate is subducting underneath the continental plate. So we end up with this trench. And these trenches are some of the deepest places in the ocean. In class, I'll show you what happens to something if you send it down into a trench. And then the other cool thing that happens is that as this plate goes deeper, deeper, deeper down into the interior of the Earth, it gets hotter and hotter and hotter. And so the rock that is part of that ocean crust starts to melt. And as it melts, it becomes less dense or less heavy, and it actually starts to rise. And as it rises, this is where we get some of that magma from, and it comes up to the surface in the form of volcanoes. So we end up with these continental volcanic arcs. So if you've ever wondered where do we get these volcanoes that are on land instead of in the middle of the oceans, this is how we get them, because some of that plate that was subducted now starts to melt and it comes up. And this is actually how we get some of the volcanoes that are on the west coast of the United States. For example, there's a whole chain of mountains out in Washington and Oregon, Mount Rainier and Mount St. Helens. All of those volcanoes that are out there were formed this way. The second type of convergent plate boundary that can occur is when two oceanic plates converge. So you have an oceanic plate and an oceanic plate. Now in this case you would think, wait, which one is going to subduct underneath the other one? They're both oceanic, they're both dense. But there's usually one that is a little bit more dense than the other, a little heavier, denser than the other one. So dense means heavy. So we talk about denser plates being heavier. So there's always one that's a little bit heavier, has more dense minerals and more dense rock in it, and that's the one that's going to subduct underneath the other one. So the same thing happens. Where those two collide and you have the subduction occurring, you end up with a valley, and so you end up with a trench, an ocean trench. And because these are ocean crusts that are colliding, you do end up with the melting of that ocean crust when it gets deeper and deeper and deeper into the earth. And then that magma rises up to the surface and it forms volcanoes. But because this is not continental crust over here, this is oceanic crust, now we end up with a volcanic island arc instead of a volcanic continental arc. These are the kinds of volcanoes that form Japan. So Japan is made entirely of volcanoes that are part of a volcanic island arc. And our third and last type of convergent plate boundary is when you have two continents colliding. And so if neither of these plates in this case is going to be subducted, because these are both fairly light in terms of their density, they're not very heavy, and so they stay upward. They don't tend to subduct underneath. So in this picture, you can see that the continental crust, which is this light colored crust, stays up top. You might have oceanic crust underneath there, and that gets subducted, but the continental crust stays on top. And when this happens, they just smush together. And when they smush together, they don't really have anywhere to go but up. And so this is how we end up with these really, really large, really tall mountain ranges. And the perfect example of this is in the Himalayas, Mount Everest, which is the tallest mountain on the earth. And this is how we end up getting that. And the way we ended up getting the Himalayas, Mount Everest, is when India, this is the continent of India, about 71 million years ago, it started to move north and it collided with the Asian continent. And as it collided with that Asian continent, the Himalaya Mountains were formed right here. And so Mount Everest is in the Himalayan mountains where the continents of Asia and India collided about 10 million years ago, about 5 to 10 million years ago, they collided together. All right, this is your last check for your understanding. You want to choose the answer that matches the boundary with the correct effects. So is it number 1, convergent or ocean to ocean? Does that form mid-ocean ridges? A convergent plate boundary, continent to ocean, does that form, is that when plates are colliding together? A divergent plate boundary, is that when plates slide past each other? Or is it transform when new ocean floor is created? Feel free to go back to your notes and check up on these before you choose your answer. And hopefully you chose the correct one, which was number 2. Convergent plate boundaries is when plates are colliding together. We don't get mid-ocean ridges when we have convergent plate boundaries. That's when we have divergent plate boundaries. And a divergent plate boundary is therefore when we get mid-ocean ridges, not when plates are sliding past one another. This would be a transform plate boundary. And this is new ocean floor being created. That happens also when we have a divergent plate boundary. So hopefully you got those right. And you are done. Great job. Just remember to bring your notebook to class on Monday. So Monday, that might not be tomorrow. And that's going to be December 3rd, which by the way is my birthday.